All right, I'll give you a quick introduction. So we're gonna have a talk from Sai Linn Thu. He's a field engineer at Solo.ai based in Singapore. Started his career in networking and had experience with private and public cloud infrastructure in a lot of industry like banking, financial services, aviation. And now he's in the field engineering team at Solo.io and focuses on modernizing microservices from edge to service mesh.
All right, thank you so much. Hope everyone can hear me okay. All right, Sai, welcome everyone for the talk. My name is Sai. I am a field engineer working at Solo.io. I'm based out of Singapore. So today what I'm going to talk about is delivering business values with Istio. So I seen like a few of your folks like joined yesterday the workshop about what is Istio, and then today we're going to talk about from a little bit from the business side, and some of the content is going to be a little bit of like reading. So yeah, let's get started. Today agenda going to be about like I'm going to talk about four agenda. One is around the business driver. So why do we adopt Istio? What are the benefits that we can get from the Istio? What is it benefits to your business organizations and growth? So one is around the key concepts. So like if you are already familiar with Istio, this may be a little bit boring for you, but it's going to be a little brief. And then the third agenda is about the use cases. And then the fourth is about the path to glue platforms. I'm going to wrap up with the how we Solo help our organization to succeed with adopting the Istio. So that. So when we talk to a lot of our customers and our engineering leaders, our community members, what are the most important business drivers for adopting Istio? So eventually there are many, and this isn't an exhaustive list, and but I would say three most common business drivers for adopting Istios are: the first one is around the security, the second one is the observability, and the third is resiliency. Again, this isn't an exhaustive list. There are like others mechanisms like progressive delivery and how Istio can be used for advanced deployment architectures like a Canary deployment, and then like helps organizations to release their software faster in a more secure and stable and consistent way. So So let's start with the security. So we all fundamentally understand that security is super important. And then in 2022, State of the Kubernetes Security Report sponsored by Red Hat, and we found out that 93% of the organizations reported that at least one of the security breaches found in their Kubernetes environments in the last 12 months. And then 31%, which is 1/3 of the organizations, say that they have experienced the security incidents, and as a result of that, they lost revenue and the customers lost in the last 12 months. So what is the magnitude of that? So if we take a look at here on the right-hand side, as a result of the security breaches, average cost of the security breaches is around $4 million. And then if you take a look at the left-hand side, if we zoom in a little bit further into more of the verticals like the healthcare and financial and pharmaceuticals, so the prices, the average cost of the security incidents cost goes up to $9.2 million. So this is around the security. So the next one is about the resiliency, the why organizations adopt Istio. If we take a look at this report by IHS and the IDC, Fortune 1000 companies and cost the downtime because of the resiliency issues is about the $1 million per hour. So what is the resiliency? Why it is so important? So resiliency means like anything related to your service outages. It may be your network outages, storage outages. It may be your infrastructure cloud provider outages, right? So that's why the resiliency is so much important. And then then especially in the highly regulated risk industries like finance, pharmaceutical, and the healthcare and the public sectors. So the cost going to be goes up to $5 million per hour. And then, but not only those like large scale organizations, if we take a look at like scale down a little bit to the mid-sized organizations, it's going to cost you about $1 million per year because of the resiliency incident. So beyond the cost of the resiliency incidents, if we take a look at what are the more beyond the cost, what are the impacts, it's more on the around like lower customer satisfaction and the loss of revenue and the reputation loss and loss of customers. So that is one of the reasons that customers looking to adopt Istio. Observability. So if we take a look at the report from the State of Observability in 2022, this is sponsored by Splunk. And Splunk, if we look at the data in that report, Splunk categorized the organizations in 3 different levels. One is the beginner, one is the intermediate, and one is the leaders in the observability. So how do they adopt observability in their organizations? So based on that, if we take a look at 75% of the those leaders in observability, they adopt the observability in their organizations, reported that they have improvement in the problem detection time. So which is like sometimes it may not be the outage, it may not be the problem, it may be the smoke that it's about to happen. But with observability, like you level up your game in observability, it can detect earlier, and we can do a lot of preventive measures and solve the problem before the outage. And then 69% of the MTTR, when we know the problem is happening, when we can pinpoint your observability, your issues, where is it happening? If your observability is really great at that, and you can do 69% like MTTR, mean time resolution, to solve the problems before it happens to some catastrophic failures about large scale outages. And then like 73% is improvement in the deployment times, because most of the time we don't want to deploy your software release in the big bang approach. We want to leverage on the Canary. So while we're doing the Canary, observability is so much important. Like the traffic will be slowly shifting from your software version 1 to the version 2. Look at your observability, everything is great, and then slowly we move the traffic from like 90% of the traffic to version 1, 10% of the traffic to version 2, and then 80-20, 70-30, 60-40. That's how we leverage the observability and do your Canary deployment and do your software releases in a more secure and stable way. So that is why 73%, if you are level up in your observability game, and 73% of the organization reported that they have the improvement in the deployment time. So this is really interesting data that we found on that. So one of the reasons that customers like adopting the Istio is observability. This is the third key point. And what about the impact of observability if we are not in the on the games? So according to the report, so if your organization is in the beginner level, some of the you have the observability, but you don't really have like a full-blown observability dashboard or metric or logging and monitoring all these. If you're in the beginner stage, 23.8 million lost because of you don't have the observability issue and you cannot solve the problems ahead of the time. And if you're the leaders in the industry, found out that they have the like a 10 of the cost of the beginner compared to beginner, it's only like $2.5 million cost of the downtime. So we talk about like the importance of the observability, security, and the resiliency, and then why do we adopt Istio? These are the 3 most important business drivers for adopting Istio. And let's take a little bit about the key concepts of Istio. So if you're already familiar with it, it may sound a little bit boring for you, but like if you are like new to the Istio, this key concept will be a lot of beneficial to you. So as we all know that organizations are constantly migrating from their monolithic architectures to the microservices. So what when we migrate, and then after that, leveraging a lot of technologies like containers and Kubernetes and serverless, and also the cloud providers. It may be on the on-prem, like OpenShift you are running on OpenShift on-prem. You may have running on the EKS, AKS, and GKE, and all these kind of like running across your services in a distributed fashion. So, so one of the most important things to think about is the design consideration for your application networking. We call it application networking. So that's where you break it down your monolith to the microservices here. So all of your microservices now started to need to connect. So this we call it application networking. And what about security? All of these microservices need to communicate each other in or just with a plain text or with the security. How do we do that? And what about you have a microservices running on one cluster? That is fine. And then you have the observability for one cluster, and you have a 5 cluster within the cloud provider or across the cloud provider, and you have about 10 different observability. How are you going to consolidate that if your one microservice from AWS talking to another microservice to the GKE or Azure? How do we get the consolidated, unified versions of the observability game? So that's where the observability is another important things when you adopt the microservices. So in the past, how do we do that? So application development team, when they started to develop microservices, they pick and choose their own languages. Like example, like this team choose the Java, and then another team choose a Go, another team use the Ruby and Python and their own favorite programming languages. And then when your microservices start to scale, the most important questions that we start to think about is, what about those services need to communicate each other, need to find each other, need to communicate each other? This is called service discovery. So how do we do that? And then another point is, how do these service-to-service communication communicate securely? Is this the developer jobs or it is the platform engineering jobs? And then what about the observability? Let's say example, you develop your microservices with Java, and you will use the observability related Java related library, and you embed it in your microservices together with your business logic. And another team doing the same thing in the Ruby, another team doing the same observability with the JavaScript or Go. Then a lot of varieties, a lot of different log formats came out. So there is no consistent way of observability doing that. So these are the challenges that when we start to do the microservices. And so on the right hand side here are the challenges. Not only that, what about circuit breaking? What about retry? What about the timeout? All of these advanced networking logics. So if we think about it, these application networking logic, infrastructure logic are not differentiating your business values. These are the what developers are best at spend time writing code, focusing on the business logic that will differentiate your market, that will differentiate from your competitors. So all of these infrastructure logic is that we need to solve away from or take away from the business logic and abstract it into another layer. That's where this service mesh comes in. So we take it out this business logic and all of these infrastructure logic that we use the custom libraries. Let's say if you remember about the Netflix days, they use like libraries for the service discovery and circuit breaking and timeout and all these kind of things, and abstracted and then put into the application layer proxy. So these proxy will be running alongside of your microservices on your Kubernetes cluster. So you have 3 or 4 microservices on your Kubernetes cluster. That's fine. No, there's not much issues. But what about you have hundreds of microservices in the one cluster? What about, and you need to start to see, like, you need to break it down your Kubernetes cluster, right? You have the 100 nodes running on the Kubernetes clusters. You are doing microservice, but I talk with my colleagues, we joke about, you are doing a microservice, but you are doing a microservice monolithic. But you have one Kubernetes cluster, what that is down, that's it, right? So now organizations started to, we need to break our Kubernetes clusters. And then, with that, and your microservices started to scale, and then your all of these infrastructure logic also started to scale. So we need to configure all of these application layer proxy using some control plane. So that is the start of the service mesh architecture. We split it like a control plane and then the data plane, which is running alongside of your application. So developers, there's nothing to do with developers. Developers just focus on the the business logic that increase your developer productivity, and then all of these application, networking, security, observability logic to the sidecar proxy. So this is a bit of a beautiful picture of the Istio. Istio is one of the service mesh implementation of the service implementation. So there are some other open source implementation for service mesh like Linkerd and some other projects out there. So if you take a look at here, we have this control plane controlling the behavior of your sidecar, which is running alongside of your microservices, and then these sidecar are running in the data plane. So before service mesh, live before Istio, your microservices will be talking to another microservices in the plain text, and then they communicate directly. And then with sidecar, so now services don't talk to the another sidecar services directly. It will go through the proxy, and then the behavior of the proxy is like how we do service discovery, how do we do the security, how enforcing the certificate to communicate MTLS, zero trust, and observability. All these behavior of the sidecar will be controlled by the Istio control plane. So this is the architecture of the service mesh in a 10,000 feet. So as I mentioned earlier, Istio is open source. The project was started by folks at the IBM, Google, and Lyft, and back in 2017. And then Istio uses as a control plane, and Istio leveraged the Envoy proxy as the data plane, which is a cloud-native proxy open source by Lyft, and then written in C++ and super high performance. And then Istio was donated to a CNCF in 2022. This is one of the important as well. So like a lot of the organizations now going towards the cloud native. So making sure that when we pick and choose our technology stack, so making sure that we will be choosing from the like a CNCF, like a incubation and the graduated project, which is important. That is where the innovation is happening. So if you take a look at the on the Istio website, there are a lot of customers like organizations already adopted. According to the CNCS survey, Istio is the most widely adopted service mesh implementation. So you can see a lot of the case studies on the Istio website here as well. So I'm gonna wrap up with I only have 5 minutes left. So the use cases. One of the most of the customer looking at Istio to adopt is about zero trust security. So if we take a look at here, the we know that we do this every day. Like Alice is our web browser, and then Bob is the Google. So we have to have a secure communication. So that is a TLS. With MTLS, it's the same fashion, but now we have both sides have the certificate. We both have an identity to authenticate and to validate and to sign that who we say we are, and then we communicate each other through the MTLS. That's that is one of the most widely adopted use cases for the Istio. When your microservices A talk to another microservices, they want to have a zero trust. So if we think about like Kubernetes environment, if you remember about the traditional like a castle and moat architecture, we have the firewall in before you come into the data center, then you have a firewall prevented. You trust nothing outside of the firewall. You trust everything, right? So if you look at the Kubernetes ingress, you may have the security in the ingress layer, and then but when traffic comes within the Kubernetes, you can talk to each other freely. So again, even though you are doing the modernization, adopting Kubernetes, in terms of security perspective, we are looking back to the same old castle and moat architecture. So what we want to do is like adopting Istio, injecting the sidecar alongside of your microservices, and then that sidecar will be your identity certificates will be there, and then that's how we communicate using a zero trust. So doing the certification is implementing the certifications is easy. Okay, let's do that. Hey team, let's implement the zero trust. But you have thousands of microservices. How are you going to do the certificate lifecycle management? So most of the problems what happen is about the downtime because of the certificate expire. Certificate life is the life is too short. Like a lot of overhead to manage this certificate. So That's where the Istio comes into play. So Istio D, out of the box, is this CA certificate provider. It will do all of the certificate generations and rotation, everything for you automatically. So automation is important here for your zero trust game. This is where Istio comes into play. So another one is about the resiliency. Like as I mentioned earlier, since the Envoy is sitting alongside of your microservices, a lot of things that we can do with the Envoy. So all of your like a retry logic, like a retry, timeout, and circuit breaking, without using the traditional like those like application specific libraries, we will be injecting on the Envoy proxy all of these like circuit breaking, timeout, and retry logic. So again, with the observability, as I mentioned earlier, rather than implementing the application-specific library for your microservices, let's use the consistent observability. Let the Envoy handle for you as a consistent observability. If the consistent observability. So yeah, this is the end of the talk. Like the three reasons why business is adopting Istio is security, zero trust, resiliency, and also observability. But there are a lot of features out there. This isn't an exhaustive. So thank you so much. And if you have any questions about how the enterprises are adopting, how if you are facing any challenges with your adopting the Istio, we have the booth over there. Please come and talk to us, and we will have to listen your challenges and help to work together. Thank you all very much. So if you have any questions, thanks so much for giving me some more time. If you have any questions, I can take. Yep. Right. Yeah. So one of the most challenges, let's say customer adopted the Istio, we constantly hearing about how do we manage the Istio D lifecycle management. And then what about your ingress gateway, egress gateway, and east-west gateway? How do we do the lifecycle management of all these? Because Istio open source version, they release every quarter, like Kubernetes is every 6 months. So they need to keep up with all these Istio upgrade. And then your Kubernetes cluster upgrade, and then the Istio, you have to upgrade along the way. So this is one of the challenges that we heard a lot from our customers. So that's where our enterprise versions comes in. We have the Kubernetes CRD. We created and do the Istio lifecycle management for you, as well as the gateway lifecycle management for you. These are the challenges. Another one is about the observability. Let's say you have the multiple clusters. You are managing your observability in every single cluster, which is very silo. Again, like microservice monolith again. And then we have the management plane, which we will install the agents on every single Kubernetes cluster, take all the data to a management plane. You will have the single unified observability dashboard. So that is another challenges that our customer face, and then they talk to us to solve their observability game. Another one, the third one is about the multi-tenancy. So you break your cluster. Let's say maybe you were provided as a namespace as a service, or maybe cluster as a service for your development teams. And then how do we achieve the multi-tenancy? Let's say you have a development team. Okay, I'm gonna export my services to the development team B, or I don't want. And these are the challenges that they start to face. And especially another one is about the public sector organizations like government, zero trust. So we have to meet our compliance requirements. We have to check the box, and we can't pass the audit. So how do we implement that zero trust implementation along with the multi-tenancy? So these are the challenges that our customers face when they adopt Istio. Yes. Yeah. So Istio help with that. So that's where our management plane comes in. We have the management plane. You may want to install your management plane on the either on-prem or the cloud. And then what we do is we have the agents we will install on the on-prem, OpenShift, for example, and then you have EKS, AKS, and GKE. And all of these agents going to be controlling the behavior of the Envoy proxy. So as a platform engineering team, only deal with that management plane. And then that management plane going to be translating that CRD, Kubernetes CRD to the Istio, and the Istio will push the configuration to the endpoint. So with that, you will have a consistent configuration. So that prevents a lot of like human error.